Hello, everyone.
So,
Today we have a guest. We have Georgios with us, a fellow LinkedIn. Um, how would you call yourself on LinkedIn?
content creator, I guess.
Are you a coach?
No, um, I don't formally coach. I do coach people, but I don't formally coach them.
Mm-hmm.
Um, if people, have questions and they want to chat, they can grab one of my coffee chats and we talk.
That's great. So we've met a while ago. It's already a while ago,
Oh
and
yeah.
since then we have done a lot of content engagement together. But that was a real engagement, a really good engagement, because I really liked what you have written, and the idea
Thank you.
the way you think about things is great. And we have a lot of overlap, not 100%, but mostly 100%, I would say. And that is actually quite interesting. And that's the reason why we came together
Mhm.
today for a topic, which is actually how to break into software development, right?
Yeah.
And software development is a different thing today than it was in the past. And for many, it's overwhelming these days. And there is a lot of caveats when you join this one. And it's a little bit complicated today. And I think we want to talk about that, the specific things. I quickly wrap it up. It's not wrapping up, but the agenda is we were talking about the where is it? The junior full stack myth. That's the
Mhm.
primarily about the full stack idea, which is actually a little wrong in that place. Then we will talk about the modern roles of libraries like React, which are pretty much dominating the industry,
Mhm.
and why it is. And then, of course, a topic which is very related to that, the vanilla way. So, how is vanilla actually important or not? And the complexity of backend development and why backend development is not always the best thing to start with, especially when you have no background whatsoever.
Mhm.
And at least this is my idea about that. So I'm curious about yours both. And we want to talk about boot camps because that was a big topic, and still many people came from boot camps and probably faced exactly those things, right? As the challenges and not really as benefits because somehow it didn't work out as they thought it should have been working out, right? And that is the agenda for today. So do you want to? So you have introduced yourself already. Sorry. Um, yeah. So let's dive directly in. So we have already some people on the show today. It's great. Um, Rules of engagement. Write us comments in the comment section, and we will definitely go into those comments, discuss
Mhm.
them together with Georgios, and having just a good time here, and trying to get everyone together, especially today for, let's say, junior and aspiring developers who want to understand better what's actually going on in the market and how to actually, yeah, get
Mhm.
into this space or move on in that space because it is equally complicated these days to do that. Okay.
An extra bit on logistics. I'm handling logistics today for chat. If anybody is uncomfortable asking publicly, you can DM me on LinkedIn or on Substack, um, and ask your question that way, and then I can anonymize it, and still we can still have a conversation that way. Otherwise, we're monitoring LinkedIn chat, LinkedIn, so replying to the post or using the right side chat if you're using the LinkedIn video editor. The mobile experience will be slightly different. And of course, we're looking for YouTube comments as well. Looking forward to it. If you don't know what to write about, tell us what you're dealing with, what your context is in your career that made you show up today.
First people. Hello, Tom. Hello, Stefan.
Hello, Stefan.
Hello, Carlo. Hello, Sanjeev. And we need to have another background image because that is very
Yeah,
disturbing right now.
It is.
yeah.
Yeah,
Let's
where is
put
it? There it is.
that one. Yeah.
Good.
There we go.
Fine. So let's start with the first topic, the junior full stack myth, and that's a very interesting one because full stack was a big thing in the past, but the big thing was about that there was not much front end back then. So front end, and this is now what I'm telling out of my own experience. Front end back then was more a thing you was basically you need to do to create something, right? So as a backend dev, you were just putting out some HTML and CSS, and you try to make it work somehow. Later on, we used jQuery for this. Sometimes we used even things like ActionScript or Flash back then, but mostly HTML, of course. And that was, yeah, the full stack approach. That was, a focus on the actual backend thing and a little bit generating front end as an output. Today, front end is not an output. Front end is an own discipline and an own entire, probably an entire industry these days. And it can be from, SEO websites, web apps, native apps, or hybrid apps. And even, hybrid apps, that's actually it. And that's a very complicated thing. So saying that, hey, I'm a full stack engineer would mean that you, in your tech stack, your company or your product team uses, you can actually do everything. That is, in theory, possible. But my first question into this round would be, is it actually effective to think like that these days? And now I'm stop waffling and passing the word to you.
So let me give you a brief historical background, right? The reason we have full stack, or we had full stack, is because when the web started taking over, or when the web started in 1995, I was old enough to actually have programmed PHP, Cold Fusion, vanilla HTML. So when the web started, it was easy to create static things. And then people wanted something more. They wanted to put stuff online. And with Amazon coming out as a big player, and I don't know if you remember, but there was a bubble in the 2000s of everything and anything that was an idea and could go on the web, it did.
Yeah.
So anyway, PHP and MySQL started coming up. And PHP was actually a technology where you could create anything, front end and back end, and connect it to the database with beautiful ease, if you ask me. But then we started moving away from those with, Flash and ActionScript, and then it just became its own thing when we got HTML, CSS, and JavaScript. So there was a natural progression of things from the, I guess, OG full stack, who was the PHP developer who would write backend and front end in one package. And then eventually things started breaking out. And I'm even going to suggest that today we don't just have front end and back end developers. We also have the UX designer, who is the person that's going to create the look and feel. And the front end programmer is the person that's going to take that look and feel and turn it into a working website or a working mobile app or a working front end of any sort. And that's, with all of those specialized tools that we have now, it's very difficult to keep up to date with, your database stuff, with your backend languages, with DevOps, CI/CD pipelines, front end technologies, and be able to design well. I can't design at all, by the way. If you give me a design, it will be horrible. If you ask me to create a design, but I can take a design and turn it into something that's workable, because I don't claim to be a front-end programmer. I'm very much into backend, although I would be able to code up something for the front end. But I'm not gonna claim that I'm a front-end developer, because I'm not. Does that make sense?
In some way.
Totally.
So-
Yeah.
So,
So
For context, 20 years ago, 25 years ago, the normal expectation for look and feel was that there will be no animations. There will be no, I get a static document and the page will reload.
Mm-hmm.
And if you're not on the web, if you're on the desktop, then there's Windows MFC, it was just a window, it had a next button, or it was a spreadsheet, and there was zero animation, zero reactivity. If you resize the window, it was expected to just glitch out and take a while.
I'm going to interrupt you there and say that, and that's where Cold Fusion, and I'm not aware of many people who know what Cold Fusion is. It was a backend server and front end development tool that basically allowed you. It extended HTML with tags, and it did exactly what today's Angulars, Reacts, all those frameworks are doing. It was doing that in the early 2000s. Extremely expensive. I don't know if it survives even today. I've lost track.
There are some very exotic projects in Cold Fusion still today.
There are always these exotics, right? It was in the era of Flash, I think, somewhere around that. So it would Cold Fusion and Flash were pretty much compared in many ways, though they were different. Regarding UX and being a designer or not, I would say that front-end is often related to the design aspects.
Yes.
And in most teams I know, the front-end developers are actually no designers. Even though there are examples where this can happen, especially in smaller teams where the front-end person is in the same moment a media person and does both at the same time. That can happen as well, but I don't think it's a must-have because especially when you take a look at the UX people, the UI people who work a lot with Figma or Adobe XD or something like that, then you basically have already some kind of blueprint which you need to build then, which is of course a gap between those both worlds, so you need to have good communications in order to make that work. But I think the developer doesn't necessarily needs to have, let's say, a talent for design. I think that is not necessarily necessary. In that
I agree. Yeah. And that's why I'm saying there is that distinction. And I guess 10 years ago, you wouldn't find a UX designer. You would find a developer who would also design the UI and create the front end of whatever you were doing. But nowadays, we have all those specializations for a reason, right? You can't expect of somebody to know everything. It's not the 80s anymore. We're not doing command line interfaces. We're doing something that wants to draw people in. We want to provide experiences that are natural, simple. We want to provide experiences that can be done by children, by older adults. So there's a lot of things that a designer needs to understand in order to be able to design something effectively. And that's why I'm saying that's its own discipline. And then you've got front-end developers who will take that design and they will turn it into code. And that's another set of problems because, whatever the designer can design doesn't mean it transfers exactly to the front end. And then you've got that forgotten hero, the back-end developer, who is actually responsible for making everything work, but nobody sees their work ever.
Especially when the era of the MVP came, many MVPs started solely in the front end and became the facade, right? And this is the reason why we have frameworks like Next.js these days, which are driven by front end is the primarily thing, and we have a little bit of back end which is supporting that, the typical back end for front end architecture. That is basically came from the industry needs, where you start with something someone can see. And the backend people today, especially when they build those services, most of the backend people are often not known to the product, and I think the people furthest away or farthest away from the actual, let's say, user base, which is sad in some because it is an important thing as well. And that's another reason is that backend people are often related to infrastructure as well and working closely with the infrastructure people, because the infrastructure of a front-end person is actually inside a browser, inside an app wrapper, or inside some form of web view or something like that, and not so much really on the actual thing. Okay, that changes a little bit because the actual topic was a full stack approach, and I think when we take now those things together, let's quickly stay by something like Next.js, which is based on React, which is the next topic, and we have the bootcamps, which was one of the topics as well, and the MVPs, and then we have this typical new way of thinking where you have these, where the front-end developers actually doing full stack with an idea of, hey, we have some express functions or serverless functions in some cases, in some like Vercel's thing. Is that actually, in your opinion, is that something viable? So starting as a front-end person and just doing the back-end part, which is, taught a little bit these days by the bootcamps.
So first of all, let's back up a little bit and say that if you're an aspiring developer, or if you're a person that wants to do a career change, aiming for front-end development is very doable. But I also want to say that it's very doable to aim for back-end development. It all depends on what you want and how much time you're willing to invest in the different technologies, and we'll talk about that later. But to answer your question, it's possible to do anything, right? Technology gives us the tools to do anything right now. And yes, it's possible for me to learn a bit of JavaScript, throw an Express.js server, and create a beautiful application. The problem is that those applications usually don't really scale, and that's where the problems begin. It's a great way to build your MVP. It's a great way to pitch your product. It's a great way to put it out there so that people can see it. And it's a great way to understand the nuances, if you will, of both front end and back end, and what you will have to deal if you're one of the two when you're talking to the other of the two. Because we're talking about two different teams, if you will, sometimes, or different people who need to have very good communication. If the message that the front end is sending to the back end doesn't entirely match, then you've got problems. If the output of the back end doesn't match the requirements of the front end, you've got other problems. And if the states are all messed up, then we go into huge problems. And that's where React and all the other frameworks are coming in to help. So I would say that if you want to break into development in general, yes, pick JavaScript. In my opinion, though, and I am extremely opinionated on this, I would not go with JavaScript if I'm starting to learn programming right now. I would go with either Python, or if you're, if you really want to torture yourself, I would go with Rust, Golang, and even C++. And the reason that I always say these, that I always propose these languages to people who ask me what they would need to learn is, if you learn C++ as at the basic level, then you start seeing the problems that memory creates for you. You need to understand the connection between the software and the hardware. You get to understand your tools much better. And it's much easier once you start looking into data structures to see the problems, to see the ways that you can manipulate these tools, because everything is a tool, right? The way that you can manipulate these tools so that you can actually increase your understanding and your fundamental knowledge of what we're doing, software development.
Yeah. So, yeah, I'm not sure if I would recommend Python these days, because Python is definitely an interesting language, and it's the ML language basically on right now, and it's interesting. But people said that 5 years about Java, not because of ML, but Java was 5 to 6 years ago. This, you need to do that still, it's great. And these days, people don't recommend Java anymore. And what I can see is in the last 15 years, one of the languages which gained most tension was definitely JavaScript. Even though Python is more used than JavaScript, but in a very specific way, which means that this is right now zeitgeist and it can change, while JavaScript is growing. It is even said that JavaScript with bun can be as fast as Python. There were some tests out there because JavaScript itself is in my opinion, beautiful language. Itself, it's very readable. It's of course they haven't invented it, right? But the pattern of it. But it is actually a very nice language. But I think there is a lot. As I really say that there is a lot of competition out there. So JavaScript is very much the most crowded thing right now on the market because it is so easy to get in. You just go into a browser and you can start doing things these days. It's a little bit like the PHP of back then, when you had the first language where you finally could do something without understanding the ecosystem of Microsoft or Java in that case. You could just fire up a Apache server and you were good to go. These days it's a Node server and you're good to go. And it's pretty easy to do. Although static websites can be basically done with just a text editor in a browser. So that would be my take. I would say that JavaScript is the most easiest thing to work in right now, to start, but probably not the easiest to actually find a job.
Well,
that's what I think.
I totally agree. However, in my opinion, again, it's not the best teaching tool. So it is the easiest language to pick up, or one of the easier languages to pick up, but because of all the hand waving around types, around the dynamic model, around there's things that it covers from you, shelters you from, and so you don't get the slap in the face that C++ or C is going to give you when you exceed your array bounds, for example. So there's something to be said for both approaches. That's why I'm always saying, look, if you want to learn how to write software, learn C, C++, Golang, Rust. I would even go as far as saying, pick up a functional language like Erlang, like Scala, to get that rounded understanding. If your goal is to get a job as soon as possible, then go with JavaScript, go with CSS, go with HTML, and I would even propose TypeScript instead of JavaScript. We've had this discussion. And I do believe that because TypeScript is a more solid JavaScript, it's easier to pick up once you learn a bit of JavaScript and then move to TypeScript. It's easier.
Exactly. So people often say that when you learn, so you should learn JavaScript before TypeScript. I understand to say learn JavaScript / TypeScript before React. That makes sense. But it doesn't make sense to learn not TypeScript, because TypeScript is just the mature way, the way which explains better what's actually behind it and removes the looseliness, because you don't want to build an application on this loose typing anyway. This is not what you want. That was a mistake in the past because it needed to be quickly, fast, and it was just a scripting thing back then. Today, things evolve. We want to do real software. So I'm working in code bases up to 80,000, not up to, starting from 80,000 lines of code, just the front-end part. I don't want to see plain JavaScript anywhere anymore. That is not what I want to see there. When you have multiple people working on that, that ends in absolute chaos over time, and you will build your next legacy system today. And this is not what you want to do. And probably we're going to the next topic now, which is then React, I would say. So maybe why first of all React? So I would quickly share something for the audience. Share screen, allow, window. I was a little bit late with that one.
It's all right.
There it is. It's a little bit old because they were very late last year, and they just started with a State of JS 24 surveys. So if you're interested, you can go on the website and start the survey. It's an extremely interesting website to take a look at. And what we see here is actually that's a good industry benchmark right now. I've done a lot of videos about that, and we see clearly that React is up here. And this is the reason why we're talking about that. And here we basically talking about usage right now. It is going up even, right? In interest, it is not the biggest thing anymore, but that is what is actually, what tells you.
But that's the percentage of respondents, and they had to pick a few.
Yeah.
That doesn't mean that the interest is declining. That just means that there are now multiple options, and people who use React might also use other things.
Exactly, but it is the same effect that we had with WordPress, jQuery, those kind of large things which scaled from some point on. That once things have this motion, right, this momentum, they tend to not go away anymore. So in React does have the most tension of all the reactive frameworks, including Angular, and this is the reason. This is what I just wanted to quickly show you there. This is why we're talking today about React, and why. And another thing is, most people who start with their career start or say after half a year or three months even, hey, I'm a React developer now, not a JavaScript developer, not a TypeScript developer. I'm a React dev, and this is where I want to pass the word now to you, Georges.
Yeah, I totally agree. It's very hard to not use a framework these days. And I don't care if you're a front-end developer, if you're a back-end developer, you need that support from libraries if you're a back-end developer, or from a framework if you're a front-end developer. We're not going to recreate, or we're not going to rediscover the wheel here. If I want to do something fast, I'm going to pick a technology that's going to allow me to do something really fast. And any framework out there, Vue, React, whatever you want to call it, Angular, they give you that power to begin creating something and focus on those parts that are very, very specific to your problems, rather than to the overall problem of, let's see how to work with the document model, or let's see how to work with the DOM structures in the front end, or hey, let's see how to grab a character from the keyboard, because you can go as far as that if you're talking about assembly or C++, or C. But the real power that these things give you, the frameworks give you, is that they open up avenues of problem solving in easy ways.
Yep.
And for me, if you're an aspiring software developer and you've decided you want to do front end, go ahead. learn JavaScript, learn CSS, learn HTML, but then do yourself a favor and learn one of these packages, one of these frameworks. It's going to pay dividends, and it's going to make you more employable. Because let's be frank, there's no company today that is going to employ you because you know JavaScript.
Yes, that's there are some companies actually, but extremely rare, and you need to find them. So I created a video in the last weeks about why React, in my opinion, is still relevant even next year as the most relevant thing, even though there are other, let's say, libraries and frameworks which are probably more interesting or people talking more about, but that is interest, as I said. And React is simply the ecosystem of the industry. So we're talking about web standards and we're talking about industry standards. And many people tend to say that, hey, you need to learn web standards because web standards are, let's say, the very fundamentals you need to know. It's a little bit like you need to know about your craft. You need to know about those things. Those are for you the web standards. But if you just know the web standards and you don't know the industry standards, you are not employable. That is the big problem, because all the companies want to have an ecosystem. They want to know, when we pick React, then we have the largest base of ready-to-use developers we can hire. And if you can respond to that by, hey, I'm starting to become a React dev. This is what most bootcamps do. They train you to be a React full-stack dev, right? To just do those things and be prepared for that. And that is, so the bootcamps were a response to the bell we had in 2000, I think. It was 2000, 2001. 2020, sorry, to 2020, 2021. And because there was this extreme demand, which was a year later already gone, but that was this thing, that this is where the demand came from. And everyone in the industry, or small companies as well as enterprise companies, wanted to have something based on a good and solid ecosystem. And that was actually, as far as I remember, the ending of the vanilla era. So the jQuery stuff, where we just saw, let's say, the front end as a scripting thing in the front end. It was the era when we really saw, now this is app development. We saw React Native, React, between both worlds. We see React comparing to Flutter or native app development. Those kind of things occurred. We saw Microsoft moving all their software onto PWA-like applications put into Electron and stuff like that, based on JavaScript, but with libraries like React. And they still use React today, or Angular in some ways.
And so, and that's exactly right. However, a bootcamp prepares you for exactly what you said. It doesn't give you the total understanding. It's exactly what it says. It's a boot camp, and people who went through boot camps, I very much enjoy talking with them because they know their craft very well. So they are focused and they know their craft very well, and they can do what they say they do. My only observation to anyone who has gone through boot camp would be, that's great, but I would go in and read a bit about computer architecture, read a bit about cloud technologies, read a bit about the use of machine and software connection, I guess you could call it. And that will only increase your understanding of your craft. So, yeah, you can be a JavaScript developer, you can be a TypeScript, you can do whatever you want. Get that framework knowledge, and then for your own understanding and for your own growth and development, go back and say, okay, what other things am I using? And we don't realize it, but our main tool is the computer. That's our tool, And because we deal with software so much, we don't think about the tool that actually runs the software. And because now everything is cloud-based and everything is so abstracted away from the software developer, we don't think about, hey, you know what? Yeah, this is an EC2 machine on AWS, but it's an actual machine with memory that needs to be calibrated correctly, and it needs to have enough space when you're doing all those huge queries from the database and you're grabbing all that data. And all those, I guess, things that we are now sheltered from, but we need to understand at some point, because if we don't understand those, that's where we hit inefficiencies, that's where we have lags in software, and that's where we open security doors to people who really want to hurt our software. And so, yeah, if, again, going back to the person that wants to break into software development, I don't want them to feel overwhelmed when they hear me talking about all these things. I want them to realize that there's a very nice path that they can follow. And that path says, okay, what do you want to do? Well, I want to do a little bit of everything. That's great. Start with something that is visually pleasing, like JavaScript, and then move on to React. And if you find that you don't enjoy that too much, it's easy to pick up another language once you have that foundation in any language. So the path is there, and it's simple. Pick a language, learn it. If you don't enjoy it, pick another one and learn that. And in my mind, nowadays there are three big avenues to walk through, if you will. And you're absolutely right about vanilla. And I'm going to include vanilla with React and say JavaScript, TypeScript, React, vanilla, whatever. That's one avenue. The other one is the Microsoft route and the Microsoft tools. That's a great ecosystem to start on or to move to if you don't enjoy the JavaScript, vanilla, or React ecosystem. And then there's all the other nuanced languages which are based on Java and C. And for those of you that are feeling particularly adventurous, try the functional route with Lisp, ML, Haskell, Miranda, Erlang, Scala, all those languages that actually are used today. For example, Erlang is used today by a lot of companies, and it's a wonderful language. It has a slightly steeper learning curve than everything else. But that's because it's functional programming. However, and I'm going to end with this, if you learn functional programming, then everything else just becomes so simple and so clear to program. It's not even funny.
I think that is, so of course, functional programming is not what we see in React, of course, because we are mostly functions these days. But there are some similarities between these both worlds. And we saw that clearly when React moved away from classes and went to the route that you have clearly the ideas of the component, the higher level component, and the hook. And those, let's say, those Lego bricks were then the way how you basically functionalize your application and focus on the paradigm function equals UI functions, UI equals function state. And that is the actual paradigm behind that. So you focus on a state and everything else should arrange basically based on the state, how it actually state looks like. And you basically do that by functions, which is the reason why I personally think that if you like functional programming and the way how functional programming was in the past and it's still practiced today, even though there was this video from God, I forgot his name. I forgot his name. Sorry when he hears that. But
It's either Prime Gentile or Fireship.
No,
Or Dave Farley.
Dave Farley. Oh God.
There we go.
Dave.
There we go.
Sorry, Dave. It's a long day.
Those are the top 4 YouTubers.
Yeah, he basically made a video about that 2 weeks ago. I think is functional programming dead, and it is basically not dead, as you said. Georges is not dead. But it is questionable if that is a good starter thing, in my opinion, if you really need to have a job. So I think the best middle ground still is going back to the idea of what is the strongest ecosystem and comes close to that, and that would be probably React, Vue, or Svelte.
Or the Microsoft stack.
Yeah. The Microsoft stack is very powerful. Even back in my day, nowadays it would be C# with one of the frameworks.
Yeah. Exactly.
But back in my day, you actually had the full Borland stack as a precursor to getting into the Microsoft stack, especially with the included databases that they were often integrating with DB2 and the various Berkeley DB and similar technologies. So what happened is that you could start off with something like Pascal, Turbo Pascal, and then go to Visual Basic, and then Visual Basic, and then Visual Basic became Visual Basic.net, and then that started getting integrations for the Microsoft frameworks, and then you learn the libraries, and then you learn that you can access the libraries not only from Visual Basic but also from F# or C#. So as you learn their libraries, for example, if you were to learn React with JavaScript, well, once you know React with JavaScript, then you can maybe start tinkering with TypeScript. But in the Microsoft stack, it became a little bit easier to sort of measure maturity on, okay, you want to be the functional declarative route to go F#, you want to stay with the more imperative web-based programming style, go with C#. Then there's F* if you're going to go really hardcore functional. That one's a little bit less known. And I think the Elixir framework on Erlang. I do hope I didn't mix those up. What was it, Haskell? No, Elixir is on Erlang, right?
Elixir, I think, is in Erlang.
Okay, thank you.
Not sure, but
please correct me if I'm wrong, because I do. It's been a while, and I do mix them up.
Please comment if you know it better.
Well, we do have some comments, but regarding the path on the Microsoft stack, just because we say Microsoft stack, you don't immediately have to jump to C#.
Exactly.
You can start on C++. You can start on Visual Basic.
TypeScript. You can start on TypeScript. Yeah.
You can start on TypeScript. TypeScript, Microsoft is the majority source funding for TypeScript.
Well, Microsoft, created TypeScript basically. So,
well, they got the brand name. TypeScript did exist in the past in various different. We had CoffeeScript, ActionScript.
It was the main driver.
We had a lot of different typed, semi-typed JavaScript ecosystems or ECMAScript ecosystems that compiled to JavaScript. Then we had non-JavaScript languages that compiled to JavaScript. When the whole, Google invented Git, and that was the precursor to Angular, where you were writing Java. And nowadays, I think the Kotlin side of development is very similar there, where you're basically typing on a strict language that then has certain deliverables that do compile over to JavaScript in some cases, in some forms. But when it comes to, we talk a lot about language, and I do want to highlight Brooks' comment here. I find JavaScript is one of the most common to be sold to beginners in both bootcamps and online courses. Well, that has a reason. It's because, there's such a huge demand, plus there's such a huge interest from people doing career shifts into development, that they create this whole synthetic ecosystem, like a marketplace, that asks the question, what language should I learn? Right? So they're not really looking for a job. They think if they answer the question, what language should I learn, they will get a job. And so this sort of, I wouldn't say it's a false, I wouldn't say it's a misconception, but the identity of I like programming comes first, and then comes the language, and then comes the career, right? If you're not a programmer, and I see this with a lot of people who have aspiring software engineer on their LinkedIn title or their LinkedIn headline, and say, no, if you're an engineer, you're an engineer. This is not typical engineering where you have to have where the title engineer has some legal implications. Same thing with lawyers and doctors or MDs. If you're a programmer, developer, engineer, call yourself a programmer, developer, engineer, and just tell us what you tried so far. If you call yourself an aspiring engineer and you don't know how to code, that's already putting the cart before the horse. Right? It's not the right way about the problem, because the language is just a tool. We often say we're polyglots, but we have a preference. But I don't look for clients or customers who want something developed in PHP. I usually look for clients or customers who look for something in a very particular niche, in a very particular problem space, because you are solving problems with software. So you're building software to automate some workflow, to have much more, to get humans uninvolved with some kind of data management or process management or workflow management, or just scaling something into the digital era that was shaped in the sort of brick and mortar days. But people ask me which language should I learn? Oh, learn the fastest one, right? And then they optimize for, okay, which language gives me the most compute per kilowatt hour spent? And then they say C, and surprisingly, Python is very high on that chart. But that's, an e-commerce shop, a mom and pop's small business that sells perfume for drop shipping and has a Shopify application with some plugins, and they need a developer. They won't sell, their sales are not being done by amount of kilowatt hours of compute being invested into the web store. That is not the criteria by which their business operates. Amazon does, because at their scale, it is a huge compute problem. Heat, power, just the amount of manpower used, even the frequency, the layovers, turnover of employees. How often does knowledge get lost? How long does onboarding take? These things then you optimize for, but only in large companies.
Yeah. Well, you optimize for them in small companies as well. This is what I can say. So you try to be very quick in onboarding. You try to be very easy in readability. You be good in simplicity. Try to avoid complex things, and that is why you need to focus on the right things. That is where we can come back to ecosystem. An ecosystem which is strong, an ecosystem which is large, is not complex. In most cases, it's actually evolving into some mature, non-complex thing. So the variety of things can be complex, but once you have decided for one way, which is viable, then you see that the more you spend time in that, the more simple and more clear the things become. And this is one of the interesting parts when we get back to React and the ecosystem of React again. This is an extremely important topic for everyone, for a beginner developer and a CTO to understand, is then when you actually change the company, most of the stuff you have learned applies to the next company as well, right? Especially when you follow current patterns. When you, for example, there is this idea of that, for example, React is very, let's say, it doesn't provide you a real framework, which is the reason why it is a library, not a framework. But you don't use React in a real environment without a structure. And the structure, since there is a paradigm behind that, there are not many ways how you actually work with things like React. And so most companies have the very same pattern. Most companies in React, the most biggest, or let's say the biggest difference is actually something like a folder structure. And you can, of course, mess things up. But that is a problem of very small companies which actually don't invest into knowing how to do things, and they would mess it up with vanilla, they would mess it up with Angular, they would mess it up in general. And that is the point about as soon as you understand what you do, and that is the point that what I often say is React is not a beginner framework. React is an advanced pattern. When you understand this pattern, and most React developers somehow never read the React manual, when you have understand this pattern, which is actually a simple pattern, when you understand what high order components is, what the data flow in React is, data up, mutations up, data down, mutations up, those kind of things. When you start to understand these, how you make actually tests or do test-driven development in TDD, this is extremely transferable to every or any other React project out there, which is on the same level of maturity and professionality. That is one of those things. And when you apply for jobs, you're most likely not doing that in a 5-person business. You do that in a, let's say, medium-sized company upwards. This is where you should try to find your first job, because you need to have some form of mentoring and people who have actually time. Because let's be honest, as a junior developer, or let's say coming from a bootcamp, you are, in my opinion, not a junior developer. You are basically an apprentice. You are now starting to learn these things. You are not yet a fully self-sufficient developer who can work like a junior. You are not yet.
The biggest trap, inspiring. Sorry, go ahead.
No, go ahead. Go ahead, Dennis.
So, I just wanted to respond to what Adrian said, because I think that really hits home. Is that there's this trap that a lot of junior, I don't know, let's say apprentices, people who want to go into a career of software, and they're not self-taught, and they just didn't start organically programming at the age of 6, which is how most of us got into software. We programmed just because it was fun, right? So the same way that a piano player starts playing piano, well, they were given an instrument at age 5, and then, right, that's why they're a piano player. Not because they went to school. They went to school because they were a piano player and they wanted to become a professional piano player.
Mm-hmm.
Right? That's how we got into the industry. But if you're just going into the professional without having the identity, one of the biggest traps you'll encounter is that you'll overestimate how much you're capable of, which means that you'll give promises that are not realistic, and you don't know how to manage the risk of being wrong. Like, you need to be a very good poker player. I always say in coaching sessions that a software team needs to be very good at poker. You need to understand the upside and the downside. Okay, this is what it looks like ideally. What happens if we're wrong? How bad is it if we're wrong? How much time do we have left? How much resources or budget do we have left if we have to do it again? Would we want to do it again on purpose? What can we talk the client out of building unnecessarily? These are very important conversations that a lot of people, a lot of engineers learn only 10, 15 years into their careers, right? That's what everybody says, soft skills. But soft skills is not a course you do in a bootcamp and after 2 months it's done. If you're an aspiring software engineer, you are competing with a huge influx of developers who have 15 to 20 years of experience. And they know things and they work in a way that you cannot compete with. And there's no shortcut. Right, so you just need to go through the motion of actually finding an entry-level position where somebody can tell you what to do exactly. They will support you, and such that you are comfortable saying, I don't know how to do this. Can you show me? Or at least, can you point me in the right direction so I can learn? Mm-hmm. Your input to this process is that you need to find ways of how to make this process fun. Right, so you need to become a great student, essentially. You need to learn what makes learning React fun for you. You need to figure out what makes learning JavaScript fun for you while you're on the job. The job will teach you everything there is. But you need to figure out
in most crafting professions, you have to at least 2 to 3 years of learning, and some even 4. And so thinking that a boot camp makes you a junior developer fully fledged, simply wrong. You are a junior developer. You were basically, or still you are, when you're going, for example, into a CS degree and you basically study for years.
I'm going to disagree there as well, though. And I'm going to say that even a computer science graduate is not a junior developer. I've graduated upwards of probably 400 computer science students. And I've encountered the same questions that I encounter right now in when somebody talks to me on LinkedIn about, you know what, I have these problems, I have these questions, those exact same problems and questions come up. And it's not because one way or the other is better. It's because what we do is complex. You know, we Dennis said that our profession is pretty much the profession of solving problems. And once we understand that, then it's very easy to understand that everything else is just a tool. Your programming language is a tool. Your tech stack is a tool. So I don't understand why people, religiously stick to their tech stacks. It's like it's like a carpenter religiously saying that this is the best hammer. To me, it's the same thing. A hammer is a hammer, and it does hammer jobs. It doesn't work if you need a screwdriver. So that's.
I want to get quickly to the point again.
Please.
Right. In my opinion, so we should be differentiating between what you should be after CS degree, or what I wanted to say next was the apprenticeship of 3 years. That is another topic. In both ways, you should be, let's say, learning by yourself enough to start and take a role as a junior developer, a person who cannot work on his or her own, but needs still basically guidance from at least a mid-level developer or a senior developer, which is normal. That is basically the beginning of every craftsman journey, let's say journeymanship, right? That is what you do. I think the point is that most CS basically graduates these days probably aren't, let's say, not capable of doing that. And this is probably what you see out there. And I would argue that this is a problem of will and focus, and not so much, because I saw that in my studies as well, that there are so many people who gave nothing about really doing something. They try to get away with the least of things. This is the reason why many interns who basically want to study are already great developers, and what you could say, with a little bit more experience, that could be already a mid-level developer, right? Because the actually craft skills are already far ahead because they are so much into that craft already. So in my opinion, we should talk not about how people shouldn't behave, or let's say talk in a more professional sense, that what should a person today do in order to get a job? Because I think that is the topic about that. And now you're doing that at universities, and that would be very interesting now. What would you say needs a new person who doesn't have the nerdy, geeky background? What does that person needs to do when it comes to university, boot camp, or apprenticeship in a company?
That's a very good question. So
It's a very good question.
So to me, it's very clear. Okay. First of all, you need to like this. You need to like being challenged. You need to be a little bit of a masochist because some bugs will strain you. But no, in all seriousness, you need to have a lot of patience, and you need to like to solve problems. Everything else you can learn. And I'm not even going to go into system design and talking to clients and discussing how the client's problem
That comes naturally. That you don't have to worry about that. You don't need to learn it before you need it.
Exactly. What people need to learn is they need to learn a tool, and that tool is any programming language. And I really wanted to say this, Dennis. I think that the simplified answer to Brooke's question is all of these bootcamps start with JavaScript because it's visual. You can see what you're doing. I mean, try to do the same thing with Python, and you need a lot of libraries. You need, a lot of other stuff. Try to do it with Unity. Oh my God, it gets complicated. Try to do it with.
I would just add to that
Huh?
if you look at jobs on the web, most of them will be Java and C.
Yeah.
And then JavaScript, and then very different from the JavaScript. So the bootcamps who are promising developers that they will help them get interviews for software development jobs, the bootcamps are already targeting JavaScript companies.
Exactly.
They are sponsoring the bootcamp, so they are teaching languages where the developer can then decide, okay, backend, front end, right? So the point is, what is the language that gets us the most students, which
Exactly.
can then decide backend, front end, or full stack.
But it's not only
Java
that.
and Java and C don't make that cut. So
No.
in regards to which languages make the cut that have a lot of job listings, JavaScript is number one, or
Exactly.
JavaScript/TypeScript.
But
That's
no,
a huge factor. Because I mentored in a lot of bootcamps last year, and there was this sort of economic stance to, like they are paying money to learn. The promise is that they're going to be pitched to get a job, to get a higher chance of getting a job if they start interviewing after the bootcamp rather than before the bootcamp, because it can take a long time. There's a lot of competition, and they might not even know what a good interview looks like, right? Which is what the whole point of the bootcamp is. Like, you don't even know what it looks like if you do well. I teach interviewers and candidates alike, and with the interviewers, the hardest thing to teach them is to just get them to explore what does a good interview for you look like.
But most mid-level developers don't know how to do that. Let's be honest.
Yeah.
Most this is a human problem. That's not a developer problem.
It's
Right?
a communication problem.
It's a communication problem, right?
Yeah.
And I just want to emphasize, when it comes to Gopal, I hope I pronounced your name correctly. Sorry, Gopal Varan. Writing code is relatively easy. Engineering software requires knowledge beyond the coding language. Not all bootcamps address this gap. So I studied computer science on a very electric engineering focused university. I dropped out in year 3 because I got a job. I got poached by a startup, and I said, okay, US it is. I saw 2 groups of people, my classmates. Those who had jobs as engineers while they were studying, and those who were studying hoping that they will get a job once they're done. Those of us who were working while we were studying were, if you're in a small city like me, we were then the tech leads or the engineering managers of the graduates who are our classmates a few years ago. And this camp that worked alongside studies, they are now VPs of engineering, CTOs, etc., founding engineers 10, 15 years later. Those who have finished the studies but didn't work alongside then have to then add an extra few years to go. The whole point of the CS degree is that you can be very quickly adapted to any kind of computer science. Like, that's the whole point. You can say, oh, I want to learn machine learning or data science, and you can very quickly, I want to become an agile coach. You can very quickly be adapted to any other career, but then you become, adaptation is very quick, and then you become the junior. A lot of people do that very slowly across 10 years, 15 years, but they start at age 5, right? Like that's the big difference, right? So if you want to go into the software space and you want to look for a job, you need to understand that nobody will hire you for a technical position if you cannot code. But we are problem solvers. Most of our work is not coding. Writing code is 10% of our time investment and mental investment. So do not optimize for it. Yes, if your ability to code is 0, you will definitely not be selected. But beyond a certain threshold, there is no more optimization you can do without a deficit if you're ignoring all the other areas. Like, okay, I know how to code. Okay, do I know how to code on a team? Do I know how to code with a team that has dysfunctions? Do I know how to code with a team that is using JavaScript on the front end and C# in the back end? That comes with its peculiarities. Do I understand how QA works? Do I know what career paths are open to me? What industry is our company in? And then these things become how do I run a meeting? How do I give feedback? How does collaborative, code sharing look like? Do we do pull requests? Do we pair? What the heck is TDD? Why is Safari talking about continuous delivery so much? There's so much to learn, right? Am I doing functional? Am I doing declarative? React is declarative, not particularly functional, but it's very declarative. You need to declare this is a hook, this is a state, this is how it works, and you put it together, and then it runs in an imperative language. That is very difficult to grasp if you've never done computer science. But the point is that the act of putting keystrokes on a keyboard is not the primary function you as a software engineer should be optimizing for. Pricing all the other areas. There are way too many other areas to focus on. So you ideally want to limit the amount of coding you're doing when you're on the job to be able to really understand, okay, what's going on? Like, should I talk my team out of coding this? Because all code you create is a liability. If it's successful, somebody will have to maintain it. If it's not successful, somebody will have to remove it, right? So as you will become a very good developer, and the better you get, the less coding you'll be doing. That's very unintuitive, because early on, once you learn JavaScript, everything, you have a hammer and everything looks like a nail to you. And you just want to crank out JavaScript as fast as possible. And then a lot of developers fall into this trap of learning how to crank out JavaScript very quickly. And then nowadays you can do that with ChatGPT or Cursor or Copilot. And if you think cranking out code is the primary solution, you have a lot more to learn, right? And on the idea of CS degrees, you get to experience the whole ecosystem, how to collaborate, how to program, how to pair, how to design algorithms, data structures, economics, everything. But you never get to experience the entire thing under the pressures of a business. That is the real
It
learning.
changes most of the things, to be honest.
Yes. Yeah, like that pressure from the business, the economic pressure from a private or a government-oriented business. That is the primary driver, the sort of the forcing function that really focuses you to holistically use all of your skills, not just your ability to type code. And that's a learning path that will take time. There's no shortcuts.
Georgios.
So I agree and I slightly disagree. There's code and there's code. Our friend Martin Fowler will come in and say, there's clean code and there's other code. So there is something to be said for understanding how to code clearly, efficiently, optimize code, and so on and so forth. But I'm going to agree in that a lot of junior developers, particularly, they over-engineer. They write code for the sake of writing code. And I've said this a million times, there's the engineer who will throw code at a problem, and there's the engineer who will rather write 2 lines of code and have everything else help them solve the problem before it comes to writing code. Now, all of those things are overwhelming all of our viewers who are aspiring or junior software developers. So I want to focus on them again and say, look, focus on learning a language first. And that, exactly as you said, Dennis, it's a threshold. It's a 0 or 1. If you don't know how to code, you can't. Once you learn how to code, sky's the limit. So once you do that, then you start focusing on what you really want to do. And that could be machine learning. It could be AI. It could be LLMs. It could be fintech, whatever. But learn how to code first. And it doesn't matter what you're learning how to code on. It could be JavaScript. It could be machine language. I don't care. Just learn it.
Mhm.
Once that's done, then you've got all of the 3 avenues that we've discussed. And once you pick one, then focus on getting your first job. And on your first job, I am adamant on this. Ask questions. I don't know how many people I've seen waiting there, sweating, feeling like they can't do anything because they're blocked on something, and they're afraid to ask the question.
Yeah.
And asking questions is why you're there, as with that.
Uh-oh. Oh, okay, very good. Georgios, you froze for a moment. I think everything is okay now.
Okay. Anyway, so yeah, pick the language, whatever it is, learn to code, and once you learn to code, that's when. So I like to. I don't know how many people are martial artists here, but there's this tendency of the beginner to say, "I want to get my black belt." The black belt says, "Oh, you know what? Once I got my black belt, that's when I started learning the martial art." It's exactly the same with software development. Once you learn how to code, that's when the things start opening up. And once you learn more things about the tools that you're using, more doors start opening up. But if you want to get a job, yes, focus on the high percentage. And that's why boot camps focus on the high percentage. Focus on the bigger things and the easier things, if you will. There's no reason to be ashamed to say, you know what, I want to do JavaScript because it's easy and it's fast for me to dive into this. So if you're an aspiring software developer, then do yourself a favor and code. Write code, because writing code gets you more experience, and the more code you write, the more you learn. And I've seen code I've written 3 years ago. And I'm like, I can't believe that I wrote this
I
code.
have the same sometimes in 3 weeks.
And if you want a challenge for code writing, to up the ante a little bit, try to write code that somebody pays you for writing the code.
Oh yeah.
Go to any platform, Upwork, Code Mentor.
I'm even going to say you don't have to do that. Just go to your favorite NGO and tell them, look, I'm an aspiring
build a landing page of some kind, or data analysis of some kind.
Exactly.
Help a government body or your university. Just ask them, how can I help?
Exactly. Yeah.
They either pay you, or they can give you some kind of vouchers or hardware, or access to some cloud platform, credits, or a license to an IDE. You can go there and solve a problem. But primarily, you will be, if you're looking at Upwork, you'll be overwhelmed by the list, because there's a bunch of things you don't know how to solve.
Yeah.
And then try to make progress on the thing that is most interesting to you. It's like, okay, why do I not know how to solve this? This seems really simple. It's a low budget thing. Maybe maybe a seasoned engineer takes a few days to do this. Why do I think it's impossible? And then try to figure out what that really is, and then start looking into it, researching into that. Because it'll give you a really good reality check of what kind of problems do people want solved. And on Upwork, you will find the kind of problems of, hey, can you code up some small server? Can you log into my WordPress and fix something for me?
Fix something, yeah.
Yeah. Can you hook up some automation with Zapier, and I need some Node.js server to send an API, or have a webhook. I need a webhook for Shopify.
These days,
somebody offers you money to do that, and you will learn the ecosystem. You will learn how to set up a project. You will learn how to deploy a project. You will learn how to harden such a project if security is a concern.
You learn integrations, which is a huge thing.
I want to add something, because we have a lot today about the not just in our show, but in the industry and in the Yeah, in the entire sector is the will to get immediately into a job. So you want to start something, you want to go through a 3-month bootcamp, and then you want to have a full paid job. Years ago, a decade ago already, we had it more like, hey, you will go for an internship, and then you will go into some form of educational system, then you are go the junior path, and then you go for several years, and maybe after 8 or 10 years, you become what others call senior, or what we basically in crafting terms called the master, right? And this is the old way. Today everything needs to be fast. And what I would recommend is sometimes to, instead of going to Upwork, go into a company and work there. Just offer yourself, or ask yourself, ask for an internship, or, and this is what I mentioned before, in many countries there are still apprenticeships available. And companies, this is where you don't earn a fully fledged salary from day one on, but it's okay. So if you have, especially if you are young, you are in many situations where you might live at home in your parents' house and those kind of things, or you are settled in some way and you can work with that. You will learn a lot in those 3 years, and you will be definitely a junior developer, a fully fledged developer after that, because from day one on, you learn the full path of working practically with those kind of things. This is what you both said. That is extremely interesting. And all apprenticeship developers I personally know are employed today, and when they were finished after that 3 years, they were all fully fledged developers. All of them. I really mean all of them, and they will all employed. So, and that is an extremely interesting route, but you need to take your 3 years. And in my opinion, it's absolutely the time you need, because no matter if you are a bootcamp person or something like that, you will see that you will need to have at least 2 or 3 years until you feel yourself halfway comfortable working in an environment with people of more experience in years than you have age, right? So that is hard to keep up there, and you won't feel comfortable, and it doesn't make sense, in my opinion, to go to a company which is looking like a startup, which is not yet paying real salaries, and they just take you because they need someone, and you need to go there to learn. That is the biggest mistake you can do, because you actually don't learn anything there. They pretend you, because you can obviously do something with code, that doesn't make you a software
You
developer.
start with a snack, not with a full job. You know,
Yes.
like, to give you context, I started coding before I knew how to write, because on the old Commodore, my brother had an old Commodore 64, and he taught me how to type load into
Load
the
8,1
yes
to start a game. That was important.
start a game.
I remember.
Because I wanted to play Donald Duck, and I didn't know what the characters meant, but I could type load. And that was my first experience with programming. And then I learned QBasic from that, basic, and then I did at third grade, I think I was age 8 or 9, I did Logo. It's a very graphic programming language. I think it's reminiscent of Pascal. Then I learned Pascal, Turbo Pascal. I mean, Logo is a programming language that is meant to teach young children how to program. Like that's the. I do have to mention
the turtle.
Yeah. Sorry.
Did you also
That's
have the turtle, or was it
that's
only?
the one with the turtle. Yeah, that's the one with the turtle. So you draw, but there is like loops and there's if
No, I'm
statements.
saying, did you have the actual turtle? Because Logo came with a turtle that had a pen.
Oh, I didn't have that.
You would
No.
download the program.
No, it was all
And
digital.
it would draw the shape that you created in Logo.
Yeah. It was on screen.
I remember.
So hang on. I just want to go through the whole chronology, because it might be relevant to aspiring engineers. So basic typing keyboard, monkey, H4, H3, basic, Logo. Then in like 4th or 5th grade, when I was, what was that, 10 years old, 11 years old, I started Visual Basic 3. And then that got quickly upgraded by Microsoft to 6. And then I started competitive programming. So that is basically, put it like in the STEM competitions, you usually have, in school, you have chemistry competitions,
Physics,
physics,
mathematics.
mathematical logics, so just the logic side of mathematics, and languages, recitation, book clubs, etc. So I did competitive programming, and in that I learned VisualBasic.net later on. And then when I went to middle school and I was 14 years old, I started building websites for myself, for my hobbies. I was into astrology. I built my astrology club's website. I helped people who had a website and make changes to their website. I helped my cousin set up an e-commerce shop. Then, like that experience, that those were my PHP days. That's how I learned PHP, HTML, JavaScript.
Me too.
And then I was 18. I went to university, and I was already well connected in the computer science, in the tech space. So I asked my couple buddies who were a little bit older than me, who were in startups, and I said, "Hey, can you give me a summer job?" So the first few months went by in university. Summer kicked in. I started programming as a student, which was 4 hours per week, and then it became 8 hours per week. And then I was mostly studying and on the side, just going into the office and coding with somebody. It was very miserably paid, like very little money for that. But the experience I got, it's like, hey, you need to, like, it's very important where you put your curlies and where you put the semicolon, and like we're trying to be respectful of other developers here who have to read your code, and sort of that discipline that instilled in me, it still stayed with me. And then another internship that was a little bit more serious, a little bit more part-time, like half-time. And then the next year, when I was 19, I was still studying, but I started working part-time, like half-time, for a local agency that did basically landing pages for brands, for brand marketing and brand communication. That was purely PHP, PHP 4 back then. And that was it. That was my junior year. And I stayed there for 2.5 years, and I absorbed information like a sponge. And then I went to a startup. And then that immediately, a few more years, the senior tech lead, team lead, and then the actual seniority kicked in as I was actually getting older and sort of understood the more business side of the problems. And then I went solo. And anybody in this room, if I ask you, you will have a very different and unique approach. But there is, what I'm trying to highlight is that there is a level of consistency to learning. I mentioned 10 different languages, 5 different forms of working, different forms of interests, different bodies of activity, right? So that's what awaits you as an aspiring engineer. You will start off, as you said, you see, because it's more educational, and then you'll learn something else, and you'll do Java, and then you do Python, and then you'll do JavaScript. And then once you know a little bit of everything, then you'll pick one, right? So don't do the picking first. Just learn with whatever it has a good course. Learn with whatever has a good lesson for you, where you're at right now, what is contextually relevant for you. And then once you get better at, just landing a internship with a agency that happens to use PHP, then you'll become better at PHP. And then you can decide, did I pick this, or am I definitely picking something else? And then that's how your career really starts.
And when you get older, right, and you reach seniority after, so I still believe in the 10K hours. So that's roughly 8 to 10 years. Then you start to become most engineers in that age become those people who think more about things, who think more about relations of what you actually do to other things, to other entities, to other people, to other persons. You think about risks, you think about those kind of things, qualities, right? Suddenly you understand what the quality word actually means. You were totally different in that way. And this is the point where you start to think about how you actually create code and why you create code. And this is where you want to have learned already how to write code. And this is, for me, it was the time where I defined for myself that I actually don't want to learn so and so many languages because I'm bored, because I was actually focusing more on the aspect of I want to understand the entire application lifecycle from beginning to end. And this is where I want to focus on. And this is not, I don't want to learn 10 languages mediocre. I want to have some which I can do very well, so I can focus on the actual important things of development. And that is the point. Coding is not the most important thing of development, which means that if you take a look into, for example, what is when we go back to JavaScript, what is important for JavaScript? You can now say you can learn the entire specification of the web standards these days. You can do that, but it's totally unnecessary to do that. You need to have a good, decent amount of it, and you will learn the rest anyway. And you need to focus on other things. How to write code, when to apply tests, how to make sure you keep quality, how to keep readability, maintainability, how to work in a team, how to do good reviews, how to do good knowledge share, how to make sure that what you build now with your team is still relevant and usable in 5 years and in 10 years, right? Those kind of things are important, not the extreme basics or the very fundamental basics. To learn them and keep learning them until the next 10 years in a detail, and you don't focus on the other things. And of course it is important to understand how the basics work, but look at these days. There are so many applications coming up which are really, really good. And these days, take a look at CSS now. Most of the people don't learn CSS at the very basics anymore. There are people, I know them from X or Twitter, right? They posting about CSS, how they create those great animations, those new selectors, those new directives, those kind of things. They talk about that. But in reality, I never saw a company out there who's actually applying those things. And that is the point. People apply the very basics and try to scale the very basics. This is how you scale things, because the nitty-gritty things are for the people who are really into that. That is in its own right some kind of an own journey you do, and it takes a long time and a high dedication to learn those things to that degree. And that reduces the amount of people you can actually acquire in order to build a business in a competitive environment where you need to produce a product and not the best implementation of web standards. And what I mean by that is this is the circumstance of the industry based on the industry standards. This is why the industry standards look like that, because they have adopted to that stance. And what I mean by that is when you learn or when you want to get into this business as a junior developer on some point, you need to understand this. Coding is the very first step you do, but it is not the last step you do. In 10 years, coding becomes more and more irrelevant. That will happen because of AI. It will become more and more something you prompt or you make sure it happens right, and you will become more the person who's actually developing the software but not programming the software. Programming is a fundamental thing which can be substituted, while the development stuff is very much related on how I do things, why I do things, what an impact does it have on people and humans, those kind of things. And that is human work. Right? And this is what we need to focus on. And most people who build software, I still know, think it's about coding. It is not primarily about coding. Coding is a mechanic. I know software developers who don't code. They use basically no-code solutions or low-code solutions. And they just do very little coding. I know software developers who work in large companies who don't code anymore. And they're just observing things and just helping others to get things done. And this is where it all develops too. And this is what we need to understand. We should understand that on some point in time, we become the theoretical persons and less the persons who actually do things, which means that we should become senior earlier than 10 years before. This is what I think. And that is what we need to understand, and especially juniors need to understand, to not focus too much on things and not learn 5 languages. It's nice to do that. But if you want to have a job and if you want to make a career, you need to learn things like TDD. Not that you need to practice it, but you need to learn it to understand why those things exist. You need to understand what clean code is, not to execute it, because I'm not believing in that 100% myself, but I understand those things. It is about understanding why continuous delivery, in almost all cases, outmatches the other patterns which you can use, branched things and stuff like that. Why is that? You should understand those things as early as possible in your career in order to know the higher level perspective of things and not dig yourself too much into some very low level things. Today, we don't work in assembler anymore, and there's good reason for that. And that is the very same with web standards and other things. They are interesting, but not more than that. They are not the foundation for you. They are the foundation for the technologies we use, but not the applications we built upon that. And that is important to understand. That was a waffling.
I agree with everything you said. And I am sure that, 10 years from now, all of those aspiring developers that are watching right now will say, oh my God, he was right. But for now, I want to put these people at ease that it's okay to feel overwhelmed. It's okay to feel that right now I'm only learning a language and you're talking about all of these. No, that's okay.
Yeah.
All you need to do is learn the language, learn how to produce, I don't want to say clean code, but I want to say code that when you read it 2 days later, you understand what you wrote, And once you can do that, go learn a framework. And once you have that basis, then seek out some form of employment. And that employment could be your NGO, it could be an internship, it could be in any kind of way. Get people to tell you what to program. Because once people start telling you what to program, that's when you start thinking about problem solving and not, oh yeah, I came up with this idea. Because when you come up with that idea, you're the master of whatever you're doing. And the problem is when other people tell you what to do, that's when things become a little more complicated. Not much, a little bit. And I'll agree that, yeah, you want to learn about testing, you want to learn about TDD, you want to learn about all those things. But I'm going to propose that once you understand the language, the framework, then learn 2 more things, Git and Docker.
Yeah.
And that's pretty much all you need. Once you understand all of those things, you're ready. You're ready to go into a team and tell them, I know nothing. I'm here to help. Tell me what you need me to do. And if you go in with that understanding and with that mindset, there's no way that any other team member is going to tell you, oh no, you know what, we don't need you, or you can't ask here. And you're going to find people who will be willing to help you if you're willing to ask and if you're willing to be helped.
That is the one we need to actually wrap up, but that is extremely important lesson. That is actually one of the big lessons in mentoring as well. Even principal engineers I know actually are afraid in a new job to tell, I don't understand this, I am late on time, and try to hide things instead of just asking for, hey, I need help. The point is, you should not just go to others and say, I haven't tried, I don't know, please help me. That is not good. You need to go there and say, hey, I have done this and that, I have tried this, I have found out this, but somehow I don't get to the point. Can we discuss that? So this is what I mentioned, sometimes with a 15 minutes budget, sometimes with a 2 hours budget. You should have some time where you try to fix things yourself. And with that findings, you go then to your colleagues. And no one will blame you. No one will, because they see what you have already prepared. And now the others, now basically need to find a solution together with you. And that is actually collaboration. No one wants to have a person who's I just want to abuse you. I actually can't do that. Please do that for me, a little bit like that. No one wants to have that, right? But being able to ask, and this is the supportive environment, is extremely important. But we need to wrap up. Actually, that was a great session, a really great session.
I very much enjoyed being here.
me too.
Thank you
That's
so much,
actually
both of you.
Thank you.
That was an interesting thing. We are not all agreeing on everything, but it's okay because that is a very variable topic, right? But in the end, I think we have agreed on what is most important for junior developers is the will to learn. And I really talk about will. It's not about I need to learn. No, I want to learn. I want to learn things, and I want to go the long run. So everything you do on the long run and focus on the long run is better than try to get some nice results in a very short term. Because, hey, after, I don't know, 8 years or 9 years of actually good developing, I got into another position. It was back then when I was starting to be a self-employed person. And I was pretty much overwhelmed by myself, all those new things. You will always be overwhelmed. The time when I needed to learn Kubernetes was overwhelming for me, even as a senior. There is always this, you need to become comfortable, to be uncomfortable, to become comfortable again. That is the way how we actually learn, right? Thank you so much for you both for having this great conversation, and looking forward for the next one in the future.
Thank you so much. Have a great day.
Thank you. Bye, everyone.
Bye. Who's wrapping up this week?
I will click the button.
Okay. Goodbye.
Bye-bye.
Bye-bye.